Oke, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And welcome back, my students, to our course. And let's continue our previous topic. So for this second meeting, we are still discussing about fluid motion. And especially for this video, we are going to discuss about Pascal's law, ya. Oke. So this one, ya, Pascal's law. Or if we translate it into bahasa Indonesia, then it becomes hukum Pascal, ya. So Mr. Pascal, ya, the name of a person that has this kind of concept, really concerned about pressure, yeah. So if you take a look on our previous meeting, then the unit of pressure is PA, yeah, and PA is the abbreviation of Pascal, ya. Jadi PA itu satuan tekanan, ya. PA adalah Pascal, ya. So people name Pascal, yeah, has concept of Pascal's law, yeah. So what is Pascal's law actually, yeah? Okay, so okay, let's say I have a tube, yeah, or I have a pipe or everything, yeah. But let's say the form of the container is like this, ya. Jadi kontainernya wadahnya seperti ini, and then on the left side here I put some kind of seal, ya. Jadi kayak ada semacam penutup gitu, ya. Okay, so this, and then also on the right side I put the same seal here. Okay, and then inside these two seals, ya, jadi di antara between these two seals, ya, I put fluid, let's say water, ya. Jadi misalnya di bagian sini saya beri fluida berupa air, ya. Okay, so let's say this one is water, ya. So this is water, which is fluid, and then this one is seal, ya. Okay, and then if let's say I have force here, so I give force on the left side, on the left seal, yeah, and then what's going on, yeah, when I push this seal, yeah, then this seal will also move, yeah. So this seal will move like the seal of the left one, yeah, the left seal will move, yeah, and so it will for the second seal, yeah, or seal on the right side, yeah. So it, in our imagination and also using our logics, this mechanism can happen, ya. Jadi secara logika memang seperti itu, ya. Kita berikan gaya di sebelah kiri ini, maka yang sebelah kanan juga akan bergerak, ya. Nah, the reason why, because when we put force or F here, then okay, so it is A. A means area. So the seal is like a plate, ya, and the plate has area, ya. Jadi plat ini dianggap sebagai plat gitu ya, dan platnya kan di sebelah sini pasti ada luasannya ya. Jadi kan dia tidak mungkin cuma satu, jadi kan dia bentuknya seperti lingkaran gitu ya. Sini ya di bagian sini ya. Nah, ini kan dia bentuknya seperti ini ya. Kemudian kita berikan gaya ya. Okay. So when we put force into an object with area, then it will generate something that we call it with pressure ya. Jadi when we have force contact with an object with area, then we got P The P is pressure So this one is pressure So there is a pressure here and in every part of the in every point of this mechanism the pressure is the same as long as the seal or the fluid is not comes out from this system so there is no any leak of the water or the fluid so the fluid is still on this place jadi dengan catatan tidak bocor kalau bocor maka tidak bisa jadi karena kalau bocor maka ketika ditekan fluidnya keluar but in this case all the system is perfect without any leak without any flows jadi sistemnya tidak cacat so when we put F here and then this is the area so in this point we got pressure let's say this one is pressure 1 and in this Pascal's law the pressure will be always the same for every part of this mechanism so in this point the pressure let's say this is the pressure 2 and then let's say we put any random point of this fluid jadi saya ngambilnya ini bebas saja let's say this one is also a point let's say we call it with point 3 and then let's say in this one is point P4 in this mechanism the pressure 1 will be similar with pressure at the point 2 and then will be also similar with point pressure number 3 and it does for point number 4 or pressure number 4 okay so we can make conclusion that if we want to know the pressure happens in this point will be similar with pressure happens in this point jadi ketika kita memberikan gaya di sini kemudian di sini ada luasannya maka di sini akan dibentuk gaya kemudian gaya itu akan diteruskan kemudian tekanan itu akan menimbulkan tekanan gaya dibagi dengan luas atau area akan menimbulkan tekanan dan tekanannya itu akan diteruskan ke berbagai poin atau ke berbagai titik dan nanti dia akan tertransfer tekanannya sampai pada bagian sini so the pressure will be transferred from this point into this point so let's say if I want to know P1 because P1 is similar with P2 then we can also formulate P1 comes from force 1 divided by area 1 so this one is area 1 and also this one is area 2 and then this is 2 1. Yeah. And then P2 is F2 divided by A2. Yeah. Okay, so this one is called with Pascal's law. Okay, now let's do some exercise using an example in this book. Yeah. Okay. Let me crop this one. I will put it here. Okay. Yeah. And then, so this one is one of application of Pascal's law. So when you visit car wash, yeah, so you will find this mechanism, ya. So this is called with hydraulic lift, ya. Jadi ini salah satu aplikasi dari hukum Pascal, ya. Kalau misalnya ingin lihat, itu bisa di bengkel-bengkel atau di tempat cuci mobil. Ketika mobil itu diangkat, ya, dia menggunakan sistem semacam ini, begitu ya. Nah, and then in this problem, we have information that the total mass of car and piston, yeah, so this one is the car and this one is the piston. And the total mass of car and piston is 3,200 kilograms. Yeah, so this one is the mass. Yeah, so I'll put this one mass. Let's say this one is this one is 0.1 and this one is 0.2. Yeah, so M1 M2 I mean, yeah, because this one is 0.2. Yeah, M2 is 3,200 kilogram, and then the diameter of piston, yeah, so piston is circle, yeah, so it has diameter, so the D2 is 120 centimeter, and this one is not international standard of unit, so we have to convert it into meter, yeah. So 120 centimeter is 1.2 meter, yeah. And then this one is D1, yeah. This one is D1. So D1 is 15 centimeters, so it will be 0.15 meter, yeah. Okay, now if you take a look roughly on this example, we are asked, yeah, to find amount of force, yeah, must be applied to the smaller piston to support the car. Yeah. So the story of this problem is you have to lift up this car, yeah, and also the piston, yeah, and the total mass of car and piston is more than 3 ton, ya. Jadi masanya daripada mobil dan piston ini 3.200, ya, atau 3 ton lebih, ya. So the problem is how much force that we have to apply into this system so we can lift up the car. Jadi gaya yang diperlukan itu berapa gitu ya untuk bisa mengangkat benda seberat ini gitu ya. Okay, now of course, yeah, this kind is the application of Pascal's law, so we have to write down, yeah, the equation first. So P2, yes, okay, in this one, in this point we got P2, and then this point we got P1, yeah. P2 equals P1, yeah, because the pressure that we give on the point 1 will be transfer ya into point 2 ya. Jadi tekanannya akan di transfer ke titik atau ke daerah nomor 2 ya. And then it must be F2 divided by A2, and then this one is F1 divided by I'm sorry, it must be F1 divided by A1. Yeah. Okay, now we are going to find every value of these symbols. Yeah, we got F2, A2, F1, and also A1. And we are going to find, the solution of this problem is when we get the value for F1, yeah, because this one is the problem, yeah. So we are going to find the solution for the F1. Okay, so firstly we have to find the F2, yeah. So the F2 is in this point, yeah. So this one is F2, yeah, and F2 is weight, yeah, the weight of the car and the piston, yeah. Okay, so F2 is weight, is the W, yeah, or weight of the car and the piston. Okay, and we use M of M2, yeah, M2 times the gravity, yeah. Okay, let's see. The gravity of this example is this one, yeah. So we use 9.8 for the gravity. So I will put this one here. 9.8 meter per second square. Okay. So the M2 is 3,200 times G, the gravitational acceleration, 9.8. And let's find the value. So you can use your calculation, and I will use my own. So 3,200 times 9.8. Yeah. Okay, so I got 31,360. Yeah, 31,360 Newton. Yeah. Okay, so we got for the F2. Yeah. Okay, so we got this one, and then we are going to find the value of area 2 or A2, yeah, area 2. And because the object of the piston is circle, so we are going to use formula of circle area, yeah. A2 is 4th times P D to the power of 2, yeah. This one must be D2, yeah. 4th P, the P is 3.14, yeah, times D square, yeah. So this one 1.2 to the power of 2. Okay, that's fine. I will use, okay, the symbol app. Okay, 4th. .14 and 1.2 to the power of 2. Okay, this one, let's find the answer. What's going on? Yeah. Okay, so I got 1.1, 1.13, yeah, meter square. And then for the A1, 4 P D1 to the power of 2. 1/4 of 4, 3.14, and this one, yeah, 0. To the power of 2, yeah. Don't forget to put the power, yeah, because sometimes students are careless, yeah. Students are careless, and I found that the student forget to put this one, yeah. Okay, 1/4, 1.15, yeah. Let's find solution. Yeah, 0.017, 0.017 meter square, yeah. So we got A2 and also A1, yeah. Okay, now let's find the solution for F1, yeah. So if you want to find the value of F1, yeah, so the F1 will be F2 divided by A2 times A1, yeah. Okay, F2 is this one, 31,360 divided by A2. Yeah, this one is A2. 1.13 times A1, yeah. 0.017, yeah. Then, okay, find it. 31,360. 1.13, 1.13, 0.017. Enter, and we got for 471.8, yeah, 0.8, yeah, because I round it up, yeah, 7, 8 to just 8, yeah. Okay, okay, yeah. So what can we got, yeah, from this calculation, yeah? Okay, let's take a look to the F2, yeah. We try to find the total weight, yeah, of this system, yeah. So the weight of the car and also it's the piston, and the value of the weight is 31,360 Newton, yeah. But using this Pascal's law, yeah, we only put 471.8 Newton, yeah, to lift up this kind of weight, yeah. So it will it really help us, yeah. It really help us as a human, yeah, because it is almost impossible for people, yeah, to lift up this car. But when use this kind of mechanism, using Pascal's law, human only just put a very small force, yeah, so it can lift up uh, an object with the weight of with the much higher weight, yeah. Okay, so it's really applicable and also helpful our daily life, yeah. Okay, okay, so yeah, so this one, I think the value is not similar with us because sometimes this one, yeah, using P 3.40, or sometimes using 22 per 7, yeah, but it's okay, yeah, it's okay. Don't be panic, yeah, because you got different um, you got different answer, yeah, because the way of calculation is different, yeah, because it's use or, yeah, instead of using area, yeah, but actually it can be also applicable, yeah. You can just put the or, yeah, but I think this calculation is more complex, yeah. Okay. Yeah, okay, so I think that's all, yeah, for this video. And after this, I'm going to make a video about the Archimedes principles, yeah. And don't forget to continue, yeah, to the next video. And um, thanks for your attention until now, and see you on the next video.